class. Welcome to week 12 of GEO108 Global Climate Change. And we are almost through with our content for the semester. This is our second to last week of new content. And so in preparation, please read chapters 16 and 17 of your Rudiment textbook. And so last week we went through the last glaciation and deglaciation. So remember that the last glacial maximum was about 20,000 years ago. And we looked at it from this large scale orbital perspective. Now, we're going to switch gears this week. And we're going to look at that time period from an anthropogenic perspective. Now, humans, or Homo sapiens, entered the scene. We evolved about 200,000 years ago. And we have been influencing the Earth system and the climate system ever since. Now, about 12,000 years ago, we developed agricultural practices, which also dramatically influenced the Earth system and the greenhouse gas composition of the atmosphere. And you'll be learning more about that in the material that I have posted for this week. And you feel free to discuss it further in the forum. And also this week, we have our final lab of the semester. And it'll be due a week from Monday on April 30th. And I've also posted an updated schedule for the semester so that you can check on the remaining due dates and see that we really are almost there. So congratulations, you have almost made it. All right. Now, so this week we'll be focusing on the evolution of humans and some different hypotheses of how the climate system may have influenced our evolution. And also we'll be looking at climate over more recent history, over the last 1,000 years. So now we're going to be looking at some different types of climate proxies. We're going to be looking more at dendrochronology, or the study of tree rings, and I have an excerpt read by Richard Dawkins on how that process works posted on the Moodle page. And we can also look at historical accounts now, actually left in journals by different people about their observations about the weather at the time. And so we can use those historical observations to try to infer what the climate was like then. And another thing we'll be looking at are the sunspot cycles, which function at much smaller timescales because the sunspot cycles go over 11-year periods. And when the sun has very few sunspots, or it's said to be at a sunspot minimum, insolation or irradiance coming out of the sun, that solar radiation, is actually less than when there are numerous sunspots present and there's more solar flares and activity. And so the energy emitted by the sun is not constant, and that influences Earth's climate as well. And we're going to be looking at, I have a couple different videos posted looking at more of a historical twist, because I think it's really fun to integrate different disciplines together into climate science, because climate influences the way we live so heavily. And so a couple things that we'll be looking at are the medieval warm period, which took place between about 1000 and 1300 AD. And it's not certain whether this took place globally, but at the very least we know it impacted parts of the Northern Hemisphere, specifically Northern Europe, where they experienced really temperate, nice climate conditions. And then following that, we go into the Little Ice Age, which took place between about 1400 and 1900 AD. And there are a few different hypotheses as to why these climate shifts took place. And so I'd like you to discuss that as well in the forum. And there are different hypotheses in your textbook on that. Some have to deal with sunspot cycles, others have to deal with volcanic eruptions. And to do stuff, my intro a little differently this week, I wanted to read you an excerpt from The Little Ice Age by Brian Fagan, and it's How Climate Made History, 1300 to 1850 AD. And I'm going to read you a few passages from chapter 3, which is the climatic seesaw. This is a quote. It begins with a quote from Francois Matthes. Glacial oscillations of the last few centuries have been among the greatest that have occurred during the last 4,000 years, perhaps. The greatest since the end of the Pleistocene Ice Age. And that was written in his report of Committee on Glaciers in 1940. Now, to begin the chapter. 15,000 years ago have passed since the end of the last glacial episode of the Great Ice Age. Since then, through the Holocene, Greek for recent, era, the world has experienced global warming on a massive scale. A rapid warming at first, then an equally dramatic 1,000-year cold snap some 12,000 years ago. And since then, warmer conditions, culminating in a period of somewhat higher temperatures than today, about 6,000 years before present. The past 6,000 years have seen near-modern climatic conditions on Earth. Like the Ice Age that preceded it, the Holocene has been an endless seesaw of short-term climatic change caused by little understood interactions between the atmosphere and the ocean. The last 6,000 years have been no exception. In Roman times, European weather was somewhat cooler than today, whereas the height of the medieval warm period saw long successions of warm, settled summers. Then, starting in about 1310 and continuing for 5.5 centuries, the climate became more unpredictable, cooler, occasionally stormy, and subject to sporadic extremes. The Little Ice Age. Little Ice Age is one of those scientific labels that came into use almost by default. A celebrated glacial geologist named Francois Matthes first used the phrase in 1939 in a survey on behalf of a committee on glaciers of the American Geophysical Union. He wrote, quote, "We are living in an epoch of renewed but moderate glaciation, a little ice age that already has lasted about 4,000 years." End quote. Matthes used the term in a very informal way, did not even capitalize the words, and had no intention of separating the colder centuries of recent times from a much longer, cooler, and wetter period that began in about 2000 BC, known to European climatologists as the sub-Atlantic. He was absolutely correct. The Little Ice Age of 1300 to about 1850 is part of a much longer sequence of short-term changes from colder to warmer and back again, which began millennia earlier. The harsh cold of Little Ice Age winters lives on in artistic masterpieces. Peter Bruegel, the Elders Hunters in the Snow, painted during the first great winter of the Little Ice Age in 1565, shows 3 hunters and their dogs setting out from a snowbound village, while the villagers skate on nearby ponds. Memories of this bitter winter lingered in Bruegel's mind, as we see in his 1567 painting of the three kings visiting the infant Jesus. Snow is falling. The monarchs and their entourage trudge through the blizzard amidst a frozen landscape. In December 1676, artist Abraham Hondius painted hunters chasing a fox on the frozen Thames in London. Only 8 years later, a large fair, complete with merchants' booths, sleds, even ice boats, flourished at the same icebound location for weeks. Such carnivals were a regular London phenomenon until the mid-19th century, but there was much more to the Little Ice Age than freezing cold, and it was framed by two distinctly warmer periods. Now, to move forward just a little bit, I want to read a couple more pieces. Unfortunately, scientifically recorded temperature and rainfall observations do not extend back far into history, a mere 200 years or less in Europe and parts of eastern North America. While these incomplete readings take us back through recent warming in the coldest parts of the Little Ice Age, they tell us nothing of the unpredictable climatic change that descended on Northern Europe after 1300. Reconstructing earlier climatic records requires meticulous detective work, considerable ingenuity, and increasingly the use of statistical methods. At best, they provide but general impressions, for in the absence of instrument readings, statements like, quote, "the worst winter ever recorded," end quote, mean little except in the context of the writer's lifetime and local memory. Climatic historians and meteorologists have spent many years trying to extrapolate annual temperature and rainfall figures from the observations of county clergymen and scientifically inclined landowners from many parts of Europe. Extreme storms offer unusual opportunities for climatic reconstruction. On February 27, 1791, Parson Woodford at Leston Longville near Norwich in eastern England recorded, quote, "a very cold, wet, windy day, almost as bad as any day this winter," end quote. Synoptic weather charts reconstructed from observations like Woodford's reveal a depression that brought fierce northeasterly winds of between 70 and 75 knots along the eastern England coast for 3 days. The gale brought the tides of on the Thames to, quote, "such amazing height that in the neighborhood of Whitehall most of the cellars were under water. The parade in St. James Park was overflowed," end quote. Thameside cornfields suffered at least 20,000 pounds worth of damage. Fluctuating grain prices are another barometer of changing temperatures, in the case that they can be used to identify cycles of unusually wet or dry weather. So, there are a couple different indicators we have there in historical records. Fluctuating prices of food, so during hard time, when the records show that prices of grains went up, we know that it was not a good year for growing those grains. And so then climate scientists can go back and try to infer what the conditions must have been like to make that happen based on several different recordings. Okay, couple more little pieces. What caused the Little Ice Age? Did small changes in the Earth's axis affect global temperatures for 5 centuries? Or did cyclical fluctuations in solar radiation lead to greater cooling? The answer still eludes us, largely because we have barely begun to understand the global climatic system and the interactions between atmosphere and ocean that drive it. There are few certainties. One is that we still live in the Great Ice Age, somewhere near the midpoint of an interglacial, one of the many that have developed over the past 3/4 of a million years. In the fullness of time, according to some estimates, in the next 23,000 years, the world will most likely returned to another glacial cycle, with temperatures as extreme as those of 18,000 years ago, when much of Europe really was in a deep freeze. Slow, cyclical changes in the eccentricity of the Earth's orbit and in the tilt and orientation of its spin axis have constantly changed patterns of evaporation and rainfall and the intensity of the passing seasons over the past 730,000 years. As a result, the world has shifted constantly between extreme cold and short warmer periods. The geochemist Wallace Broecker believes these changes caused the entire ocean atmosphere system to flip suddenly from one mode during glacial episodes to an entirely different one during warmer periods. He argues that each flip of the switch changed ocean circulation profoundly so that heat was carried around the world differently. In other words, Ice Age climatic patterns were very different from those of the past 10,000 years. All right, now just flipping forward to the very end of this chapter because it's extremely applicable today. And keep in mind that this is a historically based book and it was written in 2000. All right, so this was 18 years ago. Okay, here I go. Climate has never been a fashionable topic in historical circles, largely because, until recently, paleoclimatology was a crude and infant science. Only a handful of scholars, among them the French scholar Leroy Ladruy, Swiss climatic historian Christian Pfister, and the late British climatologist Hubert Lamb, have paid careful attention to the social effects of volatile climatic shifts in the Little Ice Age. Most historians discount the importance of climate in shaping the events of the recent past, reacting, quite rightly, against the notion that climate change was a primary and simple trigger for major historical events. No one would argue today that climate change caused the French Revolution, or that the bitter cold of 12th century Greenland caused the medieval Norse to abandon their northernmost farms. This kind of environmental determinism, with its simple cause and effect arguments, is long vanished from serious discussion, and with good reason. The historian's caution was entirely appropriate in an era before tree ring networks, ice cores, and sophisticated statistical treatments of historical data. Today, a climatologist's portrait of the annual fluctuations of the Little Ice Age looks like a fine-toothed comb gone mad, a graph of sharp-edged spikes of cold and warm, of cycles of cooler and warmer conditions plotted above and below a benchmark for today's climate. The curve never stays still, but moves up and down, sometimes sharply and without warning, or other times trending more gently. It is as if we have set sail on a climatic sea, tossed to and fro from the moment we set out on our journey through time. We will rarely experience true stability, just the occasional calm spot, a decade of settled, warmer weather, or more intense cold. The constant reality is unpredictable change fueled by complex interactions between atmosphere and ocean, by pressure swings on the other side of the world. For the first time, we place a detailed graph of changing climate alongside the momentous historical events of the Little Ice Age, not as a remote backdrop, but as a critical and long neglected factor in a complex equation of harvests, subsistence crisis, and economic, political, and social changes across. We can see how cycles of cold or of excessive rainfall rippled across Europe, affecting monarch, noble, and commoner in different ways, changing the course of wars and the prosperity of fisheries and fostering agricultural innovation. Climate change was a subtle catalyst, not a cause of profound change in a European world where everyone lived at the complete mercy of a subsistence farming economy, where the ripple effects of poor wine harvests could affect the economic welfare of the Habsburg Empire. The Little Ice Age is the story of European struggle against the most fundamental of all human vulnerabilities. And so if you're interested in reading it this summer, check it out, as you probably don't have a lot more time this semester. And just try to look at the material this week with the angle of humans' influence on climate and climate's influence on the way we live. And so I hope you enjoy the content for this week, and I look forward to reading your posts.